Hello, everybody. Welcome to lecture 6. We're going to be talking about proteins today and their functions, where we're going to find them, and why they're good for us, and how we can get good sources of protein in our diets. So, what is a protein? So, protein represents a large nitrogen-containing organic compound. And proteins are unique when compared to carbohydrates and fats, in that they have that nitrogen element. They will also have carbon, hydrogen, and oxygen, like what we found within carbs and fats. But now we're adding that nitrogen element. They compose about 14 to 16% of our body weight in lean individuals. So again, the more lean you are or the more muscle mass you have, the greater your protein content. And proteins are going to serve as our structural basis of the muscle tissue, among many other things within the body. So what are the functions of proteins? Proteins have 8 different functions. Number 1, they can serve as an energy source. Proteins can be an energy source. That's not their primary purpose, and that's not our preference. We would prefer them to be kind of spared or saved for some of these other functions that we're going to get to. However, proteins generally represent approximately 10 to 15% of our total energy needs in any given day. Function number 2, growth and maintenance. Proteins are found in many body structures, including skin, hair, nails, tendons, ligaments, muscles, and organs. Number 3, proteins function as hormones, and they contain many protein components in order for these hormones to be derived. Number 4, they can serve as enzymes. Almost all enzymes contain protein elements within them. However, they will contain some other molecules and some other things in there, but we need proteins in order to create enzymes. Number 5, antibodies. So antibodies are part of our immune system, and they're going to help us to like fight off infections. So antibodies are going to be produced by what's known as lymphocytes, or it's like a type of like white blood cell. And basically, it's like think of it as like a recipe to kill off a bad guy, basically. Okay. Number 6, they will be important for acid-base balance. They are part of hemoglobin, which serves as a blood buffer for regulating blood pH. Number 7, they'll help with fluid balance. So proteins such as albumin and globulin are going to be found in the blood, and their job is to draw fluid into the plasma. Okay, so the more albumin and globulin I have, the more water is drawn towards like the blood, for example, which would allow us to increase the amount of blood that we have. And lastly, number 8, proteins are going to function to assist us with transportation. So our hemoglobin, which is found in the blood, is going to allow us to carry oxygen. We also have lipoproteins, which is basically like a fat and a protein put together, and they're going to serve as kind of like a backpack for us to carry fats around throughout the blood. Okay, so those are your 8 functions of proteins. What is the primary function of proteins? Like, what is its most important job? And again, I just gave you a lot of 8 different kind of unique things that it can do, but its primary function is to support growth and repair. And it's easy for us to think about muscle when we think about growth and repair. And absolutely, protein is really important for us to get big muscles or for us to grow, during adolescence in order for us to, reach an adult level of strength and maintenance. However, proteins are also going to be important for growth and repair of a lot of other structures and a lot of other tissues within the body. So it's not just limited to muscle mass, it's also many other organs, systems, and elements within the body that are going to rely heavily on proteins in order for them to stay healthy and in order for them to grow as well. So as I mentioned, proteins are going to contain carbon, hydrogen, oxygen, and then the unique characteristic that they add to the mix is that nitrogen molecule. So they have carbon, hydrogen, and oxygen, just like what we saw in our fats and in our carbohydrates, but now we're adding nitrogen in the mix into the recipe. Proteins are the main structural material of the body. So again, as we mentioned, they're going to be really important not only in muscle, but many other important structural elements within the body as well. As we said, enzymes and immune function will be important. And proteins are going to be made of 20 different amino acids. Okay, so I like to think of this as like a protein is like a strand of beads, and each bead represents one amino acid. Okay, so imagine that you have 20 different colored beads, and you can string them together in any sequence with any, some are in, some are not. Sometimes you want to just use like purple and yellow. Sometimes you want to have more like a rainbow of colors. You can put them in different orders. So the options are really limitless when we think about how we can organize these amino acids to create different proteins, not only within the body, but also like within the foods that we eat. So each amino acid, so again, think of them as like one single bead in our strand. Each amino acid is going to contain a couple different biochemical components. So number one, we're going to have what's known as an amino group. And this amino group is where we see that nitrogen molecule. Okay, so the amino group is made up of one nitrogen and two hydrogen molecules linked together. And this is a unique element. Okay. When we compare amino acids to like fats and carbohydrates. Okay. Then we have an acid group. Okay. An acid group is going to contain COOH. Okay. So you can see that here. And then lastly, it has a unique side chain, and you can see that shown here. Okay. And the unique side chain looks really different in all these different beads. So we're going to take a look just to kind of show you how different they are. Again, it's nothing I'm not gonna ask you to memorize each of these and like what each one looks like. If you want to do that, you can take like an advanced biochemistry class. However, I do want you to appreciate how different they are when we look at them. Okay, so here you can see. So here we've got 6 different options, 6 different amino acids. So here you can see alanine, valine, leucine, isoleucine, etc. And again, I wanted to just point out the unique differences that we see within each of these amino acids. Okay. Um, Another factor that we want to talk about is the formation of peptides and proteins. So proteins, like we said, are a complex combination of amino acids. Most are known as polypeptides, which means they have like 300 amino acids. So again, just imagine a polypeptide is like just a strand of like 300 beads linked together in different sequences. Okay, so again, here you can kind of see that progression. So a single amino acid here, a dipeptide, di means 2, so I have 2 amino acids on my chain. Tripeptide, I have 3 on my chain. Polypeptide, I have many, so 50 to 100, and then that protein strand is over 100, likely more like 300. So here you can see a list of your essential versus your non-essential amino acids. So our essential amino acids, like we said, there's 9, and non-essential amino acids, there are 11. So our essential amino acids must be obtained from foods in the diet. So they're indispensable. We need to get these very regularly. I don't want to say every day, but we need to get these pretty regularly in order for us to maintain normal functioning within the body. The non-essential amino acids are known as dispensable amino acids, and they may be formed in the body. Okay, so again, it's not as important that we are getting each of these in our daily nutrition. However, we do need all 20 of these amino acids to be present simultaneously in order for protein synthesis to occur. Hi, honey. So if we kind of think about each of these amino acids as providing us with a unique construction material, we can understand that we need to have like a place to store these or a place where we can access all of these different types of construction material. Okay, so we have what's known as the amino acid pool. And then if an amino acid is needed for this building process, but is not present at the time of protein construction, then the protein building process will be stopped. So essentially we have think of this as kind of like your Menards or your Lowe's, where I can go get all of the equipment that I need, and those are going to allow me the opportunities to build whatever it is that I want to be building. Again, if Menards is out of stock of 2x4s or like wood or something like that, and that's something that you need in order to build the project that you're working on, then we have to stop the building process until we can get those nutrients or those materials available. So here you can kind of see what the amino acid pool looks like. So here you can see the free amino acid pool, and we're constantly getting new amino acids from our nutrition. And then this kind of shows you what happens with those. So we're going to use a lot of them for the building process, whether that's the tissue protein here. We're also going to use some, maybe 15 to 20% as our energy sources. And then we're going to break down some of those molecules and lose their waste products in the form of urine and sweat. So when we think about how this relates to our nutrition and kind of what we need to consume in order for us to have all of those building processes available, it's recommended that the average adult intake 0.8 grams per kilogram of body weight per day. This equates to approximately 15% of our total calories that we're consuming. And we can consume protein in a variety of forms. There are some incomplete proteins, we have complete proteins and complementary proteins. So an incomplete protein is a protein source that supplies some essential amino acids, but not all essential amino acids. A complete protein source includes all of the essential amino acids, so it includes all of the possibilities for those building processes. And then complementary proteins are when we take two incomplete proteins, we consume them together, and that will cover all of our bases in terms of our needs for those essential amino acids. Okay, so complete proteins, anything that is animal product or animal based, so for example, eggs, meat, all of those items are going to contain all your complete amino acids or all those complete essential amino acids that we need. If you are a vegetarian or a vegan, a lot of our plant sources are going to be incomplete proteins. So for example, if I were to consume rice and beans together, both of them separately, so if I just had beans or if I just had like brown rice, those are going to be incomplete protein sources. But if I were to consume them both concurrently or consume them in the same meal, they're complementary proteins, and they will cover all of our bases for the essential amino acids when consumed together. So this just kind of shows you an example of some complete protein foods. So these are some of those complementary options for you if you are a vegetarian or vegan. So I already mentioned rice and beans, but peanut butter on whole wheat bread, sunflower seeds and peanuts, yogurt and granola, oatmeal and milk, lentils and bread, tortillas and beans, or like a bean burrito, mac and cheese, hummus with bread, and bean soup with whole grain crackers. So again, those are some great examples of complementary proteins. So we think about this from a dietary perspective. Again, we're thinking about, for the average adult, we want approximately 10 to 35% of our total energy coming from proteins. Again, we think about that top end, that 35% is probably appropriate for individuals who are interested in gaining muscle mass or maybe maintaining muscle mass or doing a lot of exercise. They're having a lot of breakdown of proteins within the body, and so therefore they need to make sure they're consuming a lot. Okay, children and older adults, their ranges are going to differ just slightly, kind of based on, again, their overall energy intake and this possibility or need for growth. So again, we talked about the kind of the overall amino acid structure, including an amino group, the R group, which we said was unique, and then the carboxyl group and a hydrogen molecule. The byproduct or the waste product when we break down a protein is known as urea. And when we break down protein, we must remove that amine group here with the N molecule, and that's going to be secreted as this urea. Okay, and urea can be eliminated in three ways. Number one is urine. That's the main way we get rid of urea. Again, that's kind of hopefully easy to remember because the names sound really similar. Urea is eliminated in our urine. Number two option is through our feces or through our poop. And then lastly, through our sweat. So we can lose some of this urea in our sweat as well. So when we think about using or choosing a vegetarian diet, again, we are removing or eliminating our animal sources of protein. And because plant proteins are less well digested than animal proteins, it would be appropriate if we were vegetarian to increase our protein intake. So increase this approximately 10% increase. So the recommendation is that we consume 1.3 to 1.8 grams per kilogram of protein per day. And the reason for this is we have a lower bioavailability of vegetable or plant options for protein and a lower absorption rate. So bioavailability is basically like the capacity to take in foods, break them down, and utilize them. Okay, so again, we don't have 100% like usage of the calories that we consume. Some are lost, some are not digested, things like that. So these plant products do have a lower bioavailability, so therefore we need to consume more of them in order to kind of counterbalance that with our needs. So looking at some dietary guidelines for making sure we're getting enough protein in our day. So for omnivorous individuals, we want to eat a wide variety of animal and plant foods. So again, it's important that we make sure we're consuming both animal and plant proteins. And we want to try to choose animal foods that are going to be lower in fat. So again, a lot of the concerns with consuming meat is we have like a lot of fat and a lot of saturated fat in a lot of those meats. So for example, like bacon, ground beef, those types of things are going to be high in fat. So it's important that we watch for that fat intake because a high amount of saturated fat would increase our calorie intake and can lead to obesity, things like that. Eat animal foods with plant foods. So again, we want to shoot for about 70% from plant sources and about 30% from animal sources. And for vegans, we want to ensure that we are making sure we're matching up these proteins and having complementary protein foods. So we think about a protein deficiency. So protein calorie malnutrition is a worldwide problem. So again, protein is expensive, right? And it's hard to keep, right? So meat will only stay good for a limited amount of time. So we do see a lot of issues with protein deficiency all across the world. This can be related to political and economic problems and can lead to impaired immune functions. So the elderly may be prone to protein undernutrition, probably more so than just the average population. And again, according to a recent review, many 50-year-olds and older are consuming lower than their needs for protein. So 32 to 41% of women and 22 to 38% of older men are under consuming proteins. Again, some of the risks associated with this, particularly for older individuals, we've seen an impairment of immune function, particularly in this type of population where they maybe already are a little bit immune compromised. So that can be problematic for sure. This can increase our chances of infections and can also have a negative impact on bone development, bone health, as well as muscle mass and maintenance of muscle, right? So again, as we age, our body will decline in its muscle mass. So it's really important that as we age, we're making sure not only we get enough protein, but also making sure we're doing things to stress those muscles, such as, regular exercise in order for us to maintain that muscle mass. Young athletes in weight control sports might also be at risk for protein deficiency. They might experience a loss of muscle mass and hemoglobin because they're just generally restricting their calories. What about excessive protein intake? So again, this isn't as big of a concern as the deficiency of protein, but certainly, there is a range that we want to stay within. We don't want to overconsume. We don't want to underconsume. So what happens if we have excessive amounts of protein? So excessive amounts of a specific protein can cause allergic reactors in some individuals. So milk, eggs, fish, peanuts, etc., could cause gas, bloating, diarrhea, those types of side effects if we kind of overconsume them. Again, that range is 10 to 35% of our energy intake. So we're looking at, where is that upper limit? There hasn't necessarily been a clear upper limit established. However, that we do know that high protein intake poses no significant health risk to most individuals, particularly if we're getting a wide range of sources there. We indicate that the source of the protein may be related to that various risk as it relates to general health. And when we think about what does that mean, what does that entail? We're talking like eating a lot of fatty meats can really be problematic to our overall health. If I'm eating a high protein diet, but it's a good variety of sources, so I'm having turkey, I'm having chicken or like a lean chicken. I'm having salmon. I'm having beans and rice. Those are all good options in terms of healthy protein sources. So again, it's not necessarily that we're concerned with the protein itself. It's more the things that are coming alongside of that. So if I eat a lot of bacon cheeseburgers, yeah, that probably has a fair amount of protein, but it also has a lot of fat, and just generally speaking, it has a lot of calories to it. So kind of thinking about it in that way, as opposed to the protein itself, is probably a more holistic way of thinking about our health. So what are some of these excessive protein intake health risks? So cardiovascular disease and cancer, it appears as though dietary protein itself does not cause cardiovascular disease or cancer, but we do know that high meat diets can be rich in saturated fats, as I just mentioned, and there is convincing evidence that red and processed meats can contribute to colorectal cancer and other types of cancers. As it relates to kidney and liver function, the liver processes ammonia, and the kidneys are going to excrete urea. Uh, and so that's going to, if we're having a high protein diet, that's going to put a lot of strain or pressure on both the kidneys and the liver. However, we do know that for general healthy people, high protein diets don't have adverse effects on normal liver and kidney functioning. However, if I was somebody that had, liver disease, kidney disease, something along those lines, a high protein diet is generally not recommended because it is putting that extra strain on those particular organs. As it relates to bone and joint health, excessive protein intake can cause an increase in urine acidity, which may cause an increase in calcium excretion. So calcium loss is predicted to be 1 milligram of calcium for an average increase of 1 gram of dietary protein. As it relates to heat illness, again, the excretion of urea and ketone bodies in urine could lead to an excessive fluid loss and dehydration. So that can certainly be problematic if we're in a hot environment. A high protein diet can also increase our resting energy expenditure, which means we're producing more heat as well. So both of these effects are probably okay under normal circumstances, but if I'm in a hot and humid environment, this can be problematic for us. Other health risks associated with individual amino acid consumption. There's no like upper limit established for specific amino acids, but it is important that we try to maintain variety and not use any single amino acid in amounts that are greater than we would normally find in food. So again, there are a lot of supplements out there that are looking at just specific certain amino acids, and it's probably better to kind of have a more well-rounded approach to this. Free amino acids are manufactured to serve as drugs or dietary supplements, and excessive amounts can cause health problems and interfere with absorption of other amino acids and potentially cause like some GI distress or like some abdominal cramping, bloating, those types of things. It's best for us, again, as I've kind of already alluded to make sure we're consuming these amino acids through our natural food sources as opposed to in a pill form. There are some individuals that lack this enzyme PKU, and this is important for, the breakdown of amino acids. And so if we have this buildup of phenylalanine, which is one of the amino acids, this can be toxic to an individual. So again, if this was a condition that you had, this PKU, then we'd want to really pay attention to that particular amino acid and try to avoid that so that we don't cause these toxicities within our blood. So what about proteins and exercise? Let's kind of take a look at the interface between these two elements of our health. So we think about proteins and exercise. Again, we already mentioned that proteins can serve as a fuel source during exercise. However, we don't prefer that. So at rest, we're looking at less than 5% of our total daily energy expenditure coming from proteins. However, endurance training and high intensity exercise, we can increase our energy expenditure coming from proteins up to 10 to 15% or so. However, just understand and appreciate that it's really just a small player in the grand scheme of things when we think about energy expenditure. So again, we don't want to do this, right? So we want to maintain balance of our amino acids. Here you can kind of see the relationship between catabolism and anabolic activity. Okay, so basically we're looking at the comparison of muscle breakdown and muscle building. And in an ideal world, we are breaking down and building at the same rate. Or for people that are interested in gaining muscle mass, we're building more than we're breaking down. But do appreciate that both of these processes will occur kind of all of the time. Okay, so catabolism means to break down, anabolic activity means to build up. So when we think about resistance training, this does not appear to increase protein oxidation. So that means that it doesn't necessarily mean like we're burning more proteins. It may provoke muscle tissue catabolism, or the breakdown of tissues. Both catabolism and anabolism may occur during recovery, with anabolism prevailing over time. So again, we want to have that anabolic activity high. We want to have catabolism, or that muscle breakdown, to be low in order for us to have a net muscle growth, or a net muscle build. So carbohydrates and fats will serve as our primary energy sources during exercise. We know that during high intensity exercise or short duration exercise, it's really carbohydrates that are going to be your major player. It's generally believed that protein accounts for approximately 3 to 15% of our total energy needs during 60 minutes of endurance exercise. If I'm doing like if I'm doing prolonged exercise, several hours, maybe like a, 3 to 4 hour bike ride, we're looking at 20% of our energy coming from protein during those later stages of that prolonged exercise. Again, protein use as a fuel source increases when carbohydrate stores are low. So again, as we start to run out of carbohydrates, then we'll start grabbing those proteins to use as a fuel source instead. During aerobic endurance training, protein use is minimal. Again, when we compare this to carbs and fats, during dynamic exercise, we'll activate BCAA dehydrogenase, which is an enzyme that will oxidate these branched chain amino acids. Some amino acids are used to promote gluconeogenesis. And again, this is the production of new sugars. So there are some amino acids that we have that can be converted into sugar. However, as we mentioned, this isn't something that we really want to do. The reason we don't want to do this is because those proteins have a lot of unique functions that can't be done by anybody but the protein. So we want to try to kind of spare those proteins if possible. Carbohydrate availability is an important factor in determining how much protein is used during exercise. So again, if we can increase the amount of carbohydrates that we have in the body by like carbohydrate loading or consuming carbohydrates during the exercise, this will allow us to spare those proteins and save those for the recovery process and some of those other later processes. So when we think about proteins in exercise, protein use during exercise depends on three factors. Number one, the intensity of the exercise. So again, high intensity means no protein use. Number two, the duration. And we said the longer the duration, the more likely it is that we'll begin to rely on proteins. Again, we're still talking pennies here, right? So 5 to 20% of our total energy expenditure coming from proteins. Okay. And then lastly, availability of other fuels. So we would prefer to use carbs. Carbs are really like our top choice when we're doing, any type of exercise. We would also prefer to use fats. So really we want to use anything we can except for those proteins. So we'll try to kind of hold off on those. What about exercise and other protein loss? So again, we think about the urinary losses that we experience. So we'll see greater losses following intense or prolonged exercise, but losses are small, only about 3 grams per day. We'll also see some losses within the sweat, although that is also minor. And then the GI losses, so through our feces or our poop, very minimal as well, right? So again, we're looking to really hold on to those proteins so that we can use them in the recovery and building process. As I mentioned, proteins are so important for recovery, resistance exercise in particular, but also really any type of strenuous or high intensity exercise will lead to muscle protein breakdown in our targeted muscles. So it's important that we, during the recovery process, that's when we have the opportunity to build back or build up stronger than what we were before. So anabolic activity or the building process following exercise will occur 24 to 48 hours post exercise. So it's important that we're consuming proteins in the appropriate amounts and putting ourselves in a good position to experience recovery post exercise. What are the general protein recommendations for athletes? We want to consume proteins, preferably with carbohydrates before and after workouts. And again, we want to think about timing for this. Okay, so the concept of nutrient timing. There appears to be little difference in anabolic responses if protein is consumed either before or after exercise. However, we want to hit that. We want to hit that metabolic window. Okay, so we think about nutrient timing. We want to try to consume these items within 15 to 45 minutes post exercise, or like we mentioned, we can do what's called preloading and take in some proteins before we do the exercise. The protein source should contain all of our essential amino acids, particularly leucine is important for us. After exercise, we need about 7 grams for a 70 kilogram individual. Again, it's pretty easy to get this. So we need about 0.4 grams per kilogram of body weight post exercise. This can be something really small. We can look at something like a peanut butter sandwich or even half a peanut butter sandwich will kind of hit these guidelines. You can think about how we can pair this with carbohydrates in order to really optimize recovery following exercise. And if we do that, we want to follow a 3-to-1 or 4-to-1 ratio of carbohydrates to proteins in order for us to, number one, kind of refuel those carbohydrate sources, and number two, focus on the recovery process through the intake of proteins. So you've probably heard of chocolate milk as being a good option here, and the reason for that is it has that 3-to-1 ratio. It has a lot of carbohydrates, but it also has an appropriate amount of protein alongside it. Okay. So what do we need these proteins for in recovery? Okay, recovery with the use of or the consumption of protein is going to help us with muscle repair. And number two, adaptation to training. So again, we want to not only repair the muscle that we've broken down, but we want to actually build it up stronger than what it was before. And that will allow us to continue to see gains, right? We don't want to just stay where we are. We want to continually get better. So again, we want to be able to adapt to that training and get a little bit stronger or a little bit larger with these muscles each time we break them down. Again, when we think about protein recommendations for athlete, we want to be prudent in regards to these protein intakes. It's easy to get enough protein. Honestly, if you consume meats 2 meals a day, you're probably doing a pretty good job to get enough protein in. There is insufficient evidence that an increase in protein intake above these levels will enhance exercise performance. We do know that it will help us with recovery. So with consistent regular exercise, we should be able to do more and be able to grow or build ourselves stronger, maybe a little bit faster than people that aren't consuming adequate amounts of protein. Okay, experts contend that given sufficient energy intake, lean muscle mass may be maintained within a wide range of protein intakes. There's metabolic rationale for increasing protein intake if you're interested in hypertrophy or the growth of muscle, but you don't even necessarily need to exceed that 10 to 35% of total energy intake. It's important that we're consuming enough calories. And I would, shoot for that upper end, shoot for, 25 to 35%, but you don't need to do more than that in order for you to kind of maximize our hypertrophy potential. So we think about training and protein metabolism. Training induces specific adaptations in body cells depending on the type of training. So resistance or strength training in comparison to aerobic or endurance training. So in general, exercise training produces a positive protein balance that may contribute to performance enhancement. So again, basically what we're saying is we want to have like an excess of proteins kind of floating around in that amino acid pool. And the good news with that is that's going to allow us to have the products that we need to build when we go to do those building projects, right? So again, if I have the kind of base products available, I'm ready to go when my body is ready to build. What about dietary needs for strength athletes? Again, additional protein is often recommended to help support or promote increases in muscle tissue. And we know that with protein intake here, we want our strength training athletes to consume 1.5 to 1.8 grams per kilogram of body weight per day. Again, if you remember back to the beginning of this lecture, we said that for the average intake for just a healthy individual, we want about 0.8 grams per kilogram per day of protein. So again, we're about doubling that for our strength training athletes. For endurance athletes, we still almost want to double it, right? So we still need a good amount of protein, which I think is maybe a misconception that endurance athletes need to focus on just consuming like a lot of carbs, but they also need proteins to help their muscles recover as well. Okay, so again, this is going to help us to promote synthesis of oxidative enzymes and mitochondria. It's going to help us to rebuild the muscle mass that's broken down during hard interval workouts as well. So exercise scientists recommend that we consume 1.1 to 1.4 grams per kilogram per day for endurance athletes, and kind of on that upper edge for intermittent high intensity sports such as soccer, volleyball, basketball, those types of sports where I'm kind of dipping into each of those different energy zones. All right. That is all for today. I hope you have a great day, and we'll see you next time.